tell by looking around what we need to practice more on. Sure. All right, we are on our notes, page 46, right where we left off with the last video. We did. We're going to do 2 more graphs. So if you are struggling a little bit with the graphing, this one will help you with what we did before. That one not so much, but some of the concepts are the same. So here we go. Oh, I forgot to ask, did anyone have a birthday? I forgot to ask that. I have a birthday in January, because January is about over. We got everybody in January. December, we had everybody. So since school started, you've gotten your birthday, you've had a birthday since school started, August, September. Oh, Ryan? 11th of December? All right, ask your bonus question and call in some choice, right? 2 plus 2. Royce.
4.
You're the winner. Everybody
Thank
gets
you, Royce.
All right, here we go. Who remembers from the video what has to be step 1 if I'm going to graph this thing? And it doesn't have anything to do with it's a tangent. It could be anything. What is the first thing I have to do? What? No.
You have to get the half out of the...
I gotta get the half out of the parentheses. So if there is a number put to the x inside, get it out. No matter what it is, tangent, sign, whatever, get it out. So I'm gonna factor out that 1/2. Now I'm going to remember that factoring is division. Okay, I don't want confusion about this. If I said factor this, everybody would write this. It's automatic. Where did the 3 come from? It's 6 divided by 2. Factoring is division. So if I'm going to divide out a 1/2, that's the same as multiplying by 2. So this is going to be pi over 3. What is 1/2 times pi over 3? Isn't it pi over 6? Got it. Now, that has to be the first thing you do. Now, a tangent, normal, you're at normal tangent. This is your normal tangent. Okay, that's the normal one. All right? Now, what have we done to this? We have moved it pi over 3 to the right. That is called its phase shift. Yes, phase shift. And that phase shift is positive pi over 3 or right pi over 3. A phase shift is the new 0. So in a regular tangent curve, 0 is the origin, it's a dot. That dot is now here. The phase shift is the new starting point, the new origin. So now that dot is right there. Now, there's an asymptote over here, and there's an asymptote over here. And there's a handy little curve that squiggles up through. It looks like that. That's what a tangent looks like. But now I have to figure out where those asymptotes are. Okay? Now, the normal period, asymptote to asymptote, the normal period of the tangent is pi. Right? What have I done? I have divided that by a half. This number, and again, everything I've talked about except the picture holds true for all the functions. a divider. Well, what is pi divided by a half? It's not pi over 2. 2 pi. So my period is now 2 pi. Now what does that mean? Asymptote to asymptote is 2 pi. This dot is right in the middle. So if the whole thing is 2 pi, isn't this pi? So I'm going to take pi over 3, and I'm going to add a pi, which is 3/3. So where is this asymptote? 4 pi over 3. 1 1/3 pi. If I added a pi to get that asymptote, what am I going to do to get this one? Subtract. So that's going to be a minus, and this is going to be negative 2 pi over 3. My scale is obviously wrong, but I don't care. As long as you have it labeled, it's all good. Now, talk about the phase shift. Does this one have a vertical shift, a VS? No. Because the only way you have one is if, like this one's going to have one. That's a vertical shift. How about amplitude? What can you tell me about amplitude? No, no. Tangents do not have amplitude. Why not? There's no height. There's no height. So there is no amplitude ever to a tangent. Think of your sine curve. Isn't amplitude the height of the hills? Yep, no hills. What is, oh, period, we already did. Period was 2 pi. Which means the frequency is 1 over 2 pi. All right. Who remembers how I did this one in the notes? When I was standing up here talking to an empty room, how did I graph that? I graphed it as a sine first. I did a sine curve first. And why did I choose sine? Of all the things I could have picked, why did I pick sine? Because it's the reciprocal of the cosecant, right? So I'm going to graph a sine. Whoa, 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 we got a problem. So I'm going to pull that out. Remember, factoring is division. So I've got pi over 5 divided by 1/3, which is pi over 5 times 3, so 3 pi over 5. That's exactly right. Okay? Now, I'm going to do a sine curve. I know it's a cosecant. We'll take care of that in a minute. I'm going to do a sine curve. In the origin, remember a regular sine curve looks like this, right? That point is now at 3 pi over 5. Right? My amplitude of my sine curve is 2/5. And my period of my sine curve is 2 pi divided by 1/3, which is 6 pi. Remember, sine and cosine. Sine and cosine have a period of 2 pi. Tangent has a period of pi. Now what does that mean? Does that mean I'm going to mark 6 pi right here? No, no. How am I going to figure out what that point is right there? No, I'm going to take 3 pi over 5 and add 6 pi to it. All right, we'll pick up there tomorrow. Oh my gosh. So one time this week I've seen.
Yeah, one time. saw you online. That was like a fun. It is so loud. It sounds like, I know, it's like D in here. Yeah. She screamed at me. Literally, it's all you can watch the video. I put it on my TV. Yo, I just like 10 minutes. I just locked in, skipped through everything. I'm also taking better last time. Just trying to take pictures. I think I did.
But I know what I do.
All right, I will see you sometime. Eventually, I'll see you again. Bye.